Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organizations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello everybody, in today's episode I'm joined by Christoph Weis from WITTENSTEIN Cybermotor, part of the global WITTENSTEIN group. WITTENSTEIN is a specialist manufacturer of mechatronic drive technologies, and the company is a recent entrant to the space industry with the development of a highly compact reaction wheel called the Cyber Reaction Wheel. WITTENSTEIN Cybermotor is also a participant in the satsearch membership program, and today we're going to talk a little bit about the challenges of adopting reaction wheels in small spacecraft and discussing some of the insights and lessons that WITTENSTEIN Cybermotor has maybe learned in this process. So hello Christoph, thank you very much for being here today.
Thanks for having me here, of course. Just a small introduction. As you already said, my name is Christoph Weis and I work in the product management of WITTENSTEIN Cybermotor, and I'm responsible for the reaction wheel, but also for new space activities in total.
That's fantastic. That's a broad remit there for your emerging company. So it'd be really interesting to discuss the challenges that you face today. Let's start then with the technology, the sort of people that we're interested in speaking with here at satsearch are space engineers with the technical knowledge to get into the products and services and understand how they work. So in your view, what do you think the major challenges have been in adopting a reaction wheel for small spacecraft such as CubeSats?
Well, of course, first, the downsizing is very popular all around. So in the space industry, especially because weight and volume mean high potential of cost saving or new technology opportunities. So talking to our partners, the reaction wheel is necessary for the orientation control of satellites. But just the attitude control is not their missions. So this means they want to enlarge their capacities for their mission equipment as sensors, cameras, etc. And this is where we want to help them. And that is why we challenged ourselves to build the smallest reaction wheel in the market with just 2 by 2 by 2 centimeters to even fit perfectly in a small 1U CubeSat. But small, of course, would not help if there is no performance behind. So we as WITTENSTEIN took all our experience gained in the industry, the medical equipment and aerospace to build the tiny reaction wheels and even integrated an controller within this shape. But here, as you might think, also performance does also mean to withstand the harsh space environments. This means the radiation and the vacuum, where materials and components such as bearings have to be designed especially for this environment, and this was quite new for us. But harsh environments for such small and filigree reaction wheel does even start earlier than in the space. So the start of the rocket with its shock and vibration need to be considered in the design. So in summary, the harsh space environments and the performance in such small space are the key challenges in building such a reaction wheel for CubeSats and optimizing the design for the satellite's operators in the end.
Yeah, there's a lot of variables to consider and to a lot of aspects to get right. And
Correct.
yeah, so with the WITTENSTEIN, the WITTENSTEIN Group's industry expertise, I mean, there were a lot of different areas that you, as a company, presumably had a lot of expertise in. So I'm curious to find out what specific problem WITTENSTEIN chose to address when it made the decision to create a reaction wheel for CubeSats.
Yeah, so we always want to have a USP for our customers, and our main goal was to develop a compact and extremely power-dense reaction wheel with the highest angular momentum. Um, this was the goal, and I think we have impressively achieved this. But concerning the project, we quickly realized that our customers had more problems because performance in itself is good, but it has to go hand in hand with, for example, the efficiency. And this was the first learning that we had. So we optimized our reaction wheel in the perspective in many details. So the performance and the efficiency go hand in hand, especially when we're talking about acceleration times of the reaction wheel are the key here. because the faster the acceleration is, the faster the maximum angular momentum is reached. And in the end, the faster the satellite can do the maneuvers. So also acceleration time was one big task to fix in this project. So in the end, we did a lot of work to optimize the motor. That put a lot of effort, a lot of time in it, and also concerning the controller technology, we also want to build a need that the customer had and do not take a standardized product out of our shelves. So optimization that also mean that we want to have less vibration and disturbances to the satellite. And this means our rotating components, the rotor, are precisely measured and balanced so that later no interference factors disturb the operations of our customers. And for example, images remain sharp when the reaction wheel are in operations, or even when the reaction wheels are in operation. So this was really important to us to build a reaction wheel that fits for various operations and various missions in the end.
Oh, fantastic. And obviously precision is such a key element when you're talking about trying to push the boundaries of what is possible with miniaturization. So I'm assuming the process there has taken a long time to get different aspects right. And on the customer's side, then, aside from the engineering, the operation of the system when it's in use, how have you found the commissioning aspect of things? I mean, have you gone into specific areas to make commissioning easier for the reaction wheel?
Yeah, you perfectly hit the nail on the head here. Here we benefit from the experience of our industrial customers for whom rapid commissioning is a must. We offer our so-called starter kit explicitly for initial commissioning. This is an interface board between the reaction wheel and the computer, which can be connected via USB cable. And together with the Cyber Reaction Wheel Assistant, this is the graphical user interface. This offers the possibility to first commission the reaction wheel in less than 5 minutes, or I would even say in less than 1 minute, and to gain first experience. And it is therefore the perfect way for new customers to easily commission the product, to monitor the parameters of the product, and test the motion profiles of the mission on the ground. So the ease of use was the main focus here to our customers, or to bring this to our customers from the industry directly to the new space.
Oh, that's really interesting. It's great to have that industrial heritage to rely upon as you're working on in new areas like this. And that's on the hardware side of things. I understand you also have a software simulator, which is used to calculate the time for satellite movement. Could you just explain that a little bit?
Yeah, so and this really starts at the beginning of the project when we talked to customers. And there we quickly realized that customers often needed support well before they buy a reaction wheel. In particular, we often heard that our products were too small for their missions. So, out of self interest, we wanted to support our customers and show that our small reaction are very often more than sufficient for their missions. So, we built a simple tool internally that calculates the time of movement based on a few parameters, such as the size, the weight of the satellite, as well as the angle of inclination by which the satellite should be rotated. And we were surprised by ourselves how much customers were grateful to us for this statement, and thus also convinced that they no longer need a large reaction wheel, which helped us in the end. And that's even with the 8U CubeSats up to which our reaction wheels are designed. And this was good and gave our customers also a lot of confidence to get this quote and to get this feedback out of in a really, really early stage of their projects.
Yeah, I suppose that's a great way of addressing the issues in the market is build a tool that proves that your system can operate as required. So that's fantastic. But of course, the industrial adoption, the commissioning, the simulation, that's all one side of things. In space, a big area is how well the things perform in orbit. So how has the cyber reaction wheel performed as it's been tested in orbit in space?
First statement is here, our cyber reaction wheel has performed in orbit, and works perfectly fine. For example, in the NetSat project with our partners from the Zentrum für Telematik in Würzburg. And we are talking here, for example, about 4 satellites with 6 reaction wheels each. And the mission represents improved Earth observation in climate and climate change research. And the reaction wheels, together with the position control system from the Zentrum für Telematik, allow an exact alignment to observation target, but also the adjustment of the electric motor to the desired thrust direction for changes in the orbit. This enables a three-dimensional arrangement of the 4 small satellites for optimal observation and continuous tracking. And of course, there are more missions in preparation at the moment, so yeah, we are completely looking positively in the future.
Oh, great. Well, best of luck with those future missions. It does sound like you've gone to great lengths to try and test the reaction wheel in different ways, which is important. It's not just a case of acquiring that initial heritage; it's understanding the different range of applications. So now I just want to take things back a little bit. We've touched a couple of times on the fact that the Wittgenstein Cybermotor as a company has been born out of a business with industrial heritage in different areas, different sectors. So I wondered if you thought, if you had to start again with the technology's design and development, would you do anything differently?
Yeah, well, there are a lot of things we would do differently starting again. So, of course, and that's what I already said, we are coming from the industry market. So, we had to learn quite a lot about space technology. Unfortunately, the learning process cost us quite some time and engineering models. But yeah, this was also a success factor, I think, in the end. We brought together the ease of commissioning, for example, from the industry, our industrial quality and product qualification in this new industry. So, in the end, our products are highly reliable and tested on Earth and in space. And thinking back, we gained quite a lot of knowledge about the market requirements, which would have been perfectly, of course, to know before starting this project.
So that's great. It's great that you've been able to collect those lessons and those insights in a really operational way. So, talking further on the fact that you have experience in different industries, how do you think you found the commercial practices and processes in the space industry compared to some of those other areas of manufacturing?
Yeah, so I think at first it's important to mention that Wittgenstein is in a lot of branches also offsite traditional manufacturing fields. For example, in the oil business, where are the same high standards concerning product reliability as the tools are kilometer below ground and can be brought back without high cost. In addition, we are active in the aerospace industry, so the space was not too far away, speaking about high technology motors and drive technology. However, of course, the space industry is quite different concerning our core branches. First, we recognize the high amount of support. Second, and this was a pleasure for us getting to know the market, is the openness within this market. This means first the availability of data, but furthermore the change of technical challenges and willingness to share the experience. Big thanks to everyone who supported us also here and especially to the Zentrum für Telematik in Würzburg.
Oh, that's fantastic that you found the industry so open and accessible in that manner. I mean, that's always been a key part of our driving force here at satsearch, is something that we like to focus on and think that the industry is doing. So it's great to hear it, from somebody else.
Yeah, no, and that's also a really good partnership with you at satsearch here, because working together, getting information, getting requests from the customers. So this is really, really a big advantage also of the satsearch platform that we gained and getting a lot of information out of your opinions.
Oh, thank you. That's very kind of you to say. I guess my final question is: we've discussed how you have seen changes in between the space industry and other industries, and also presumably during the time it's taken to bring the cyber reaction wheel to the market and test it, and the missions that you've discussed. There has been changes in the space industry as well itself in that time. I wondered whether you had any predictions on how reaction wheel technology in general, or perhaps the new space industry, might be changing in the next few years. What are you most excited about, or what do you expect could happen?
Yeah, I think, and that's also referring to the start of our conversation. Starting in the whole industry, I think downsizing and standardization will be the main trends in this industry. I'm talking here about standardized bus systems, for example, and interfaces, which will help make the satellites cheaper. So we can adapt this to the reaction wheels, where we see a clear trend towards standardization and complete ADCS systems. Another key change will be, in my perspective, the ease of use of the products, moving towards higher numbers of satellites, and industrialization of the market will take place with lots of opportunities and new business models, of course. But I'm completely looking positively in the future of the space market, as I think we're just at the start of a really changing industry.
Excellent. Well, I think that's a great place for us to finish up the discussion. So thank you very much, Christoph. It's been really interesting to hear about your work at Wittgenstein Cybermotor and about how the developments to date have led you to where the company is today. So thank you for your time today.
Thank you. It was a pleasure for me.
And for anybody out there who would like to learn more, you can find Wittgenstein Cybermotor on the satsearch platform. And also, if you'd like more information on the products, you can go to reaction-wheel.com, where you can find everything you'll need. So thanks again, Christoph, and have a great day.
Thank you.
Thank you for listening to this episode of The Space Industry by satsearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.